Hey guys, welcome to the channel Couch Potato. How are you all doing? In this video, we will start structural analysis. It's a course of civil engineering. In this video, we will do introduction part of structural analysis. So we will be covering topics of what is definition of a structure, structural elements, types of structure, types of loads, and fundamental assumptions to keep in mind while assuming any constants in structural analysis. So let's get started. So what is a structure? Imagine an elastic body which is subjected to a system of loads under these system of loads. If the elastic body deforms, deformation takes place, then such a elastic body is called a structure. Contrary to this is mechanism. Suppose the elastic body does not offer any resistance. Important point is does not offer any resistance to the deformation, then that is called a mechanism. So this is the difference between structure and mechanism. So we'll now move on to the structural elements. So in the structural elements, suppose assume there's a frame structure. We can cover this in detail when we have come across this. So this is consisting of a column, and this is a beam. Maybe this is called as a slab. These are made of different elements. So these elements can be of maybe beam is it's a I beam, right? So we have tie rods as a structural element. We can even have channels as beams. Okay, we can have angles, Indian standard angles, etc. So these are all a part of the structure which make up the structure. Okay. Next, moving on to the types of structures. So what are different types of structures? Imagine you're crossing a bridge. Okay. So this is the bridge and you want to cross from point A to point B, and this is how the bridge is. Let's assume this is how the bridge is. Okay. This is the abutments. So this is a bridge. This is actually what? This is actually a truss, which is a type of a structure. You even have a cable stayed bridge, right? These are all the supports. This is a support. So this is a cable stayed bridge. So you have different types of structures, namely truss. You have cables. You have arches. You have frame structures, which we generally see in building. So these are the types of structures. Based on this, there's a classification on how the structures are classified. So what is the classification? Classification of structures, if you will. So the structures can be skeletal structure, They can be a surface structure, or they can be a solid structure. So these are the three types of classification of structures, wherein this is a skeletal, this is the frame of the building. You can assume that as a, which we have covered in previous slide. Now they can be surface structure, you can take as example as a slab, right, roof of the house, etc. So now moving on to the types of loads that can act on a structure. So what are the different types of loads? First and foremost load that acts on a structure is its self weight, or what you call as a dead load. So how do you explain a dead load? So assume a slab, right? There's a slab, maybe this is in a second floor, just for six, and this we have a couch here. Maybe we have couch potato or something there. Now we have a table. Okay, these are all the objects which are not stationary. These are not moving, sorry. These are all the objects which are stationary. This is stationary objects. You have floor finishing, right? These are all floor finishing. These all act as a load on this slab. So these are all the examples of dead loads. Now we have live load. This is simple to understand. Maybe there's a person walking from this couch to the table. That person is actually acting as a live load there. You have in certain seismic zones, you have earthquake load. You can even have a wind load. Assume there's a high-rise building, maybe in Dubai, or you have this building and people are there, and this building is subjected to wind load. Maybe more than 20 stories building. This is called a high-rise building. For this building needs to be designed for a wind load. Okay. Now we have impact load, which act suddenly. You can, in some places it is very cold and the snow gets deposited on top of the roofs. Then you have a snow load. Imagine a gable roof house in northern part of the earth hemisphere. So there's a snow load acting on the roof of the house. So these are, they're not limited to these. We have many other loads, etc. These are the some of the loads which act on the structure. Okay. Now, what are the different fundamental assumptions we need to keep in mind while going through this course of structural analysis? So, what are the fundamental assumptions? These fundamental assumptions govern the course of the structural analysis. So, we assume that the body is elastic. Secondly, we have the body is assumed to be homogeneous. Homogeneous is nothing but identical properties are displayed across all directions at all points. We even have to assume that the body is to be isotropic. This is identical properties across all directions at a point. Assume that there's a smallest or elemental part of the structure. You have, when you take different directions, load acting on this, load acting on this, load acting on this, all should be equal. This all should be same. Next, the body is assumed to be continuously solid. And the foremost and most important thing, and next most important thing, is principle of superposition is assumed to be valid. This is a very important point. What is principle of superposition? Assume that two forces F1 and F2. The summation of the forces F1 and F2, delta 1 plus 2, is nothing but delta 2 plus 1. Is nothing but the sum of the forces itself. So this is nothing but the principle of superposition. So this covers a basic introduction to the structural analysis course. We have covered different types of what is the structure, how it differs that from a mechanism, what are the structural elements which make up the structure. We have different types of structures themselves, and how do you classify the structures. And then we have seen types of loads that can act on a structure. Finally, we have seen the fundamental assumptions that have to be kept in mind while going through the course of the structural analysis. So in the next session, we'll cover how to determine determinacy of a structure, whether it is statically determinate, indeterminate, or if it is kinematically determinate or indeterminate. So stay tuned. Thank you.